Hi, it's Mr. Benson here again. So this is part 2 of our video on triangles. Now, the angles in a triangle we also want to think about mathematically. And one really important relationship here is that the angles in any triangle always add up to 180 degrees. So they will always add up to a straight angle, as we can see below, where all the angles that make up our triangle, so angle A here, angle B here, and angle C here add up to 180 degrees. And there are some ways that we can sort of understand that better, which we'll look at later on. But just as long as you remember that relationship, we can move on and start to think about triangles a little bit more. Now, one thing about these angles is that they are called internal angles because they are inside the shape. So what we can do with that, we can think about what we know about internal angles now to find the value of an unknown angle. So we know that the three angles in our triangle must add up to 180 degrees. So I could write that as 42 plus 37 plus D equals 180. And then, well, I'm going to run with that a little bit. I can simplify 42 plus 37, and that is going to equal 79, plus D equals 180. Then what I've got to think about is, okay, so what does D have to mean that 79 plus D equals 180? Or algebraically, what I'm going to say is, to get D by itself, I would subtract 79 from both sides, so 180 minus 79, and we get D having a value of 101 degrees. And then what we could do, actually, let's think about this one a little bit more. We could say some things about the triangle that might not have been, well, actually, they were kind of obvious, but we've kind of got the numbers to back it up now. We can see now that we've got three different angles, and also one of them is greater than 90 degrees. So if we were going to describe this triangle, we would say that it was scalene, because it has no equal angles and therefore no equal sides. And the other thing that we would say about it is that it was obtuse angled. So we've figured out that it is a scalene obtuse angled triangle. Okay, so now we've had a look at the idea of interior angles. We now need to look at another important idea called exterior angles. Now, if you think about the triangle below, we're probably all pretty happy with the idea that it's got three interior angles. So these are the three angles that we can measure that are inside the triangle. To create exterior angles, all we need to do is choose any side of our triangle. I'm going to work with the base in this example, and then we extend that line out a little way. It doesn't need to be very far. Now, what you can see is I've now created a new angle. So I can highlight that there. And you can see that I've created an exterior angle to the angle C, which was the interior angle. Now, we'll look at this in a little bit more detail in a moment, but one thing just want to point out a couple of things. You can do this at any corner of your, any vertex of your triangle here. So say I did this up here and I extended that, obviously not quite as straight, then I've also created an exterior angle at that vertex. Now, another thing about this is it doesn't really matter where you do it. You're going to get the same angles at each vertex. So if I had instead extended this line up here, I'm still going to get the same exterior angle. So you can see that this angle here is equal to this angle here. And in fact, the angle over on this side, again, would just be angle B again. Just trying to get a degree symbol there. Right, so it doesn't matter which vertex you do it at, all you're doing is extending the side outwards, and then you can form an exterior angle. Now, what can we actually do with exterior angles? Well, there are some important things that we can see from them. The first one is that any exterior angle and the interior angle adjacent to it are supplementary, so they add up to 180 degrees. So which things are we talking about here? So if I just highlight these on the diagram, so if we think about this exterior angle, which is adjacent to this interior angle here, which would be angle ACB. So they are supplementary, they add up to 180 degrees, and we can see that written here in a kind of more mathematical way for us. So angle ACB, which is the interior angle, plus angle BCD add up to 180 degrees, which is saying that they are supplementary, or that they form a straight line. Now, the other thing that we can see is that the sum of two opposite interior angles is equal to the exterior angle. So we were thinking about this angle here as our interior angle. Now, it was adjacent to the exterior angle, so the opposite angles must therefore be these ones over here. And so if we add these two together, now you might remember that we previously said that the interior angles have to add up to 180 degrees. So if we add the three interior angles, they must add up to 180 degrees. We also know that an interior angle and its adjacent exterior angle have to add up to 180 degrees. So we can put these two ideas together and see that the two opposite interior angles, so that is angle BAC, which is this one here, and angle ABC, which is this one up here, must add up to the same value as the exterior angle BCD. So this just gives us some tools to work with, where we can now start to perform some more calculations on triangles. So for example, we'll have a go at this one here, where our question is to find the unknown angles. And there's a few ways you can approach this one. And one thing I'd like to say is that there is usually no single right approach, as long as you're making sense and doing things logically and getting the correct answers at the end. But just be conscious that questions might ask you to do things in a certain way. So this question here, you could actually do in several ways, but I'm going to just show you one that highlights that the two relationships that we've just seen. So firstly, when I'm thinking about with the value P, or the other way of calling that one, if you think about it in terms of our angle notation, we would call that angle BAC. Well, what do I know? I know that P plus 125, which is the value of the exterior angle, must equal 180 degrees because they're supplementary. And so what that means is P must equal 180 degrees minus 125 degrees, and so P is going to equal 55 degrees. So this highlights the concept that we looked at before, which is that the interior angle is supplementary to the exterior angle, so they add up to 180 degrees. Now, the other one that I want to find is the one with the value of n. Now, because I know the value of P, I could actually just work with the fact that P, which is 55, plus 83, plus n equals 180, and I could work n out that way. But the other thing I also know from my, what we were talking about exterior angles is, so when we're thinking about, so this is angle ABC, I know that the sum of the two opposite interior angles, so that's n plus 83, must equal the exterior angle, which is 125. So what that means is that n must equal 125 minus 83, which is 42 degrees. Okay, in summary, we can now name triangles. So we name triangles based on the labels at their vertices. We put the triangle symbol in front. And so we might call something triangle ADC or something like that. Triangles are classified based on the side lengths, so we can split them into equilateral, where all the side lengths are the same, isosceles, where two side lengths are the same, or scalene, where no side lengths are the same. We can classify triangles based on the size of the angles. So a right angle triangle has a 90-degree angle in the triangle. We had acute angle triangles where all the angles were less than 90 degrees, and we had obtuse angle triangles where one angle was greater than 90 degrees. And as we could see, it was possible to have a combination of those classifications. So you could have a right-angled scalene triangle, or you could have an obtuse angled isosceles triangle. The only one that is kind of special there is equilateral triangles, where they could be acute, but they can't be anything else. Now we also saw that the interior angles of a triangle always add up to 180, and we can use that to calculate unknown values. And we also saw that interior angles always have an exterior angle which is supplementary, so it adds up to 180 degrees, and the exterior angles are equal to the sum of the opposite interior angles. Okay, so what to do now? Again, attempt the exercises, checking your answers frequently. See if you're getting things right, and then move on, especially if you're doing exercise that have got a lot of problems in them. Don't spend a lot of your time doing stuff that you find easy. Just maybe do every second or every third question if you're getting things right reliably. If you're making mistakes, definitely practice some more. So that would mean maybe working through more of the same type of problem. Check with your classmates first, see if people around you can help you. And also, if you're able to help other people, that will really help your understanding. And if you're having trouble, of course, just feel free to email your teachers.